So our first speaker, I'll get down to business because we want to finish before the pizza comes. Steve Mactaggart is our first speaker. May come up.
Hey.
Steve is my colleague at Cevo, and he's going to talk about how he used ChatGPT to solve some problems. I'm actually quite surprised. He actually inspired me to ask ChatGPT some stuff. And I asked, I don't know, it was pretty boring. It was like, give me some cloud formation to do this. It actually gave it to me. Like, oh no, Python script to do this thing. And it actually was accurate. I was quite surprised. Without further ado,
Thanks,
Steve.
Awesome. Hi, everyone. Clap. To clap myself. Well, Matt's pretty much told you what we're going to talk about for the next half an hour. But in all honesty, actually, this is a story about some investigation that we were playing with, and there's a few people in the room who've seen the outcome of this, and I thought it was a really interesting connection to what's important to me and how we kind of build technology, and some, probably not for a bunch of the people that have been using AI and LLM, you're probably not shocked by this, but to me it was a really nice story. So, who am I? I'm a bit of a coat rack of titles. I collect them at the moment. I've done a bunch of things. Currently work with Cevo. You'll see the orange everywhere. Apology for the corporate branding, but that's all really important that we get out there and sell the thing. Under the hood, really, what I actually am is a passionate technologist, right? So I think that's probably a very similar title for a lot of people in the audience today. Over the past few years, though, what I've come to realise that these are kind of two of the key motivators that allow me to get up every day and come in and help change the world and build the world moving forward, right? We wouldn't be here tonight if we didn't love the shiny, that we weren't interested in playing with new tech and seeing how it can be applied. And hopefully most of us want to actually solve problems with it and not just, the only good Kubernetes is serverless Kubernetes because it means it's turned off. No servers running Kubernetes is the best environment you can have. So we could talk about that one for a long time. But the second piece is the bit that's really important, and probably we'll see how good I am at weaving this into the undertone of today's conversation, right? But I was talking with Matthew earlier, right? Like, doing something for the first time is really easy. Maintaining it and keeping it running and keeping it operable and not breaking the people and the process in the journey is what's really important. So it brings us to serverless. Now, what you don't know about me is I was a bit of a serverless detractor for actually a fairly long time. I'm an old school Java dev for my sins. I started my life actually in VB, if I really am honest, right? And spent a lot of time building a lot of orchestration automation for sustainability around that kind of server-based toolchain. And serverless came along, and it was these functions as a service things that lived out over there. And what I experienced them from for the first part was just kind of bash scripts in the cloud that connected things together, custom resources and other bits and pieces. They never really did any heavy logic. In fact, over lunch today, that was one of my colleagues' comments, is that he kind of saw it as that you'd never write any business logic in it. That all changed in 2020, 3 years ago. And this is the Matt Merriel tie-in. So Matt and I are working on a project together, which, because it's recorded, we can't name, but I can talk to you afterwards when we're off mic. Large-scale government corporate customer that had built a huge serverless application, top of API Gateway and Lambda and DynamoDB and all the cool stuff. And it really worked. Like, it hummed. The harder we pushed it, the more we threw at it, the more we did, the thing responded. It got faster, it got more responsive, the more we pushed at it. And it was nicely decoupled, and it was nicely separated, and there was like an authorizer that lived over there, and the functions were nicely immutable, and everything was really repeatable. And I went, holy crap, I finally get it. I finally see that it's not about the technology. It wasn't about a bunch of shiny functions that we kind of run in somebody else's server, but it was a different way of thinking about the way we build systems. We compose them, we much more about Lego bricks with clear, defined interfaces that we couple together and make work. And that all the constraints that we deal with in serverless are actually good things. All the things that if you're an old grey-haired me type of human, why can't I do this and why can't I do that? Well, you shouldn't, is probably good. The reason is you probably shouldn't do it. Right? And you shouldn't worry about that. You shouldn't, not that you shouldn't, you can't, like, go do it. But you probably don't need to anymore. So things that we used to battle with 15 years ago, scaling and retries and queuing and encryption in REST and encryption in transit and patching servers and all that crap just disappears. And we can move up the value stream. We can start to play with things a little bit higher on. So in my day job, we're working with a large-scale FSI customer and we're helping them build out a cloud platform. And the key part of what we're trying to do is build a bunch of guardrails to let people do shit, have the platform get out of their way, have the system get out of their way, and no, we're not building it on Kubernetes. And allow them to have some of those constraints, force them into good patterns. Two of the key areas at the moment that are problems for us, like always, is network and identity. So I hate networking. I'm not a networking person. Sadly, I have had too much immersion in it recently that I can calculate CIDRs and recite parts of the ISO stack to you enough to sound important, but I don't like it. The reason why is as a kind of a software dev, it's really hard, from my view, to troubleshoot and debug. Right? If you have any networking issues, usually the symptom is it doesn't work. And it's one of 25,000 things that could be wrong, and all 25,000 of those things have to be perfectly lined up, and then it works. It's kind of like DNS. And it's why it works and how it's hung together is often cryptic and hidden, and it's in a dark room with blinking lights that you can't see. So the way we've solved that over the past 10 years is we tried to make things more observable. So if I can see what's happening, if I can trace the packet to a certain point, I can work out the problem must be there. Or if I can see this type of thing, and you start to be able to build these behaviours that allow you to troubleshoot. So it doesn't just go from working to not working, it goes to not working with these kinds of problems through to lesser problems and eventually working. So what I wanted to unpack for you today was a problem we had around IAM. IAM has some of similar behaviours to networking in that troubleshooting and triaging piece, especially if you're in the cloud. So we're currently working in AWS, but applies to most any kind of code-based RBAC system. We went through and we built the first generation of what we were doing pretty quickly. We threw stuff out to people, let them have access, put the guardrails in place where we thought they needed to be, and we're now kind of coming back a little bit later, closing the gaps, making sure what we actually thought people were supposed to do and what they're actually doing are two different things. Now, for the software engineers in the room, create table statement is good, easy, no risk, no one worries about that. Delete table, delete from are the ones that should scare you, right? Well, that's the same problem we had in IAM. So it's easier to give people more access because it shouldn't break anything. Well, what happens, like we found out recently, that we have to take stuff away from people. How do we not break stuff? And how do we not break stuff on scale? So we're a platform team currently servicing X number of accounts. How do we make that change with a level of confidence, like a proper software engineering team, that we're not going to break it, or if we do break it, we know really quickly. So option one is the old way. We go ask people, do you use this? What do you use this for? Do you do that? Do you do this? Or we just change it. We wait for people to scream, but they might not scream for 3 months because maybe they don't actually know that it's broken. Or we just secretly do it and cross our fingers and hope that nothing happens. And that's probably the way pre-cloud that you had to operate.
Screen test.
Screen test, exactly. So the newer way, the way I would hope most of us today, if you're operating in the cloud, is we'd go and inspect the system. We'd go and look at the logs. We'd go and review what happened, what people are using, what they're doing, what's occurring. We'd see what was there. We'd be able to identify who was using it. We'd adjust the behaviour. And so this is what we actually did. But we moved to the serverless way. So the problem here with this one, which seems like a really modern approach, is the queries that I wrote to go through and trawl the last 3 months of logs to identify if these commands were running cost us like $80. Because the size, big organisation, right? Lots of logs, big expensive Athena queries. It costs us like $80 over 3 or 4 days to do, which is okay once, which gives me forethought. It lets me go understand what's happened. But what if I missed something? What if I wrote a bad query? What if I missed a piece I hadn't looked far enough back that there was some other bits and pieces? We're doing a lot at the moment where we're trying to move things that are kind of query and poll-based to event and response-based. So this is the architecture that we ended up with. So if you can read, I'll zoom in to bits and pieces. So the first part of this is the detection component. So for those of you who aren't aware, every API event that is fired through the AWS control plane emits itself out as an EventBridge event that you can query for. The cool part is in most cases, their format is really similar. So what we actually do here is we look for any API call that has access denied in it. So what we were trying to detect, I missed that bit, what we were trying to detect was after we put this change into place, once we start to restrict things and we lock people out, how the hell will we know that we've broken things? And how quickly could we turn around and wait? Instead of you screaming to me that it's broken, I know before you even know, well, you know because your command failed, but before you realise that it's not your fault, it's my fault, I got a chance to fix it, and then you'll run the command again and it'll work. And you'll just think it was a gremlin in the system and all be happy. But it's about that real-time immediacy feedback piece, right? So the solution here is, detect those out in our edge accounts. So you can see here, this is a cluster of accounts. So a really small, costs nothing, detector that sits out as one EventBridge rule that relays that message back up into a core central account, to a central EventBridge, which runs through SNS into Lambda to then relay that back out into whatever alerting tool you want to use. At the moment, the example we have is built for both Slack and Teams because we use it in a few different domains, but it's simply, it could very easily, we're all serverless devs, I hope, very easy to extend that into whatever your alerting and notification tool of choice is. That's not too hard, right? That's not an interesting story. The bit that stopped me from building this was the Dynamo piece. I've done lots of bits and pieces. I've played with lots of things. For some real weird reason, I've never had a high intersection with Dynamo. I've seen it, it's been around, we've done a few things, but it always seems to be an effort. Every time I go to pick up Dynamo, I've kind of got to page all the Dynamo concepts. I'm like a relational boy, sorry, forgive me, but I'm going to page all the concepts back in and querying what do I do and how many keys and how does that work? And honestly, there are so many things I don't do because I just can't do that. And I knew in this scenario, building all of this without that wouldn't help because I wanted the Dynamo table to provide like a time-based block. So when something started to happen, it would send that message once and then delay all messages that looked the same way for like 12 hours, right? So we didn't end up with a Teams channel that was just spewed with 4,000 S3 list bucket commands, right? I just wanted one, we'd go and investigate and let the rest kind of get dumped off. So I needed something stateful and therefore Dynamo was the answer. But I didn't really know how to do that. So all of this comes together. We've got the Dynamo solution. And it all works, and what you end up with is something that looks like this now. So this is one of the, I don't even know what it is. It's one of my CDK build jobs that's failing for some reason. The interesting side effect on this was this is actually running on the internal Cevo Slack, where we actually have a lot of permissions. But what we found the really interesting side benefit of this pattern is misconfigured roles where people have tried to least privilege themselves and they've got a build job or something like this that they've forgotten to add. And if you've done any of that, you've troubleshooted your butt through that for a long time. What am I missing? What's it trying to do? This is a really awesome way to solve for that problem. So we can talk a bit later when I don't run out of time on other interesting applications, things like, I think I'll give you one. There's a misconfigured storage gateway in the environment that didn't have access to a KMS key to write to S3, and no one knew. They looked at the storage gateway and they looked at the file system and they went, everything's there. But nothing was in the bucket. And it was just silently failing, which seems to be a nice failure of storage gateway. And it was only that this started spewing out every 12 hours. Something's trying to write to S3 and it can't. So it wasn't even the restricted permissions that we were trying to protect ourselves from. Now, we have real-time observation of every single failed API call in the entire organisation, and it costs cents an hour to run. But here's the secret. I didn't really write it. Well, I didn't write all of it. So I said that Dynamo's the thing that always kind of hurts me. And I was talking with a mate who hopefully will watch the video later, so ADW. But I was talking with him late one Friday afternoon, and he was all hardcore up in all this LLM stuff. And I hadn't really played with it. I was a bit like, Matt. And, oh, you should do this, and it's awesome, and you can do this, and amazing. Like, blow my brain. And then I'm like, it's 5:30. Is it Friday night, Thursday night? Friday night or Thursday night? Oh, what would happen if I wrote this? Well, I got this. I got the function, and this is the actual screenshot. I'll probably flick over to the channel. It's probably easier to scroll down though. But it used like the Slack SDK, which I wouldn't. I've done heaps of Slack integration, but I don't do that. I usually just hit the webhook with the requests object. I didn't know about that. It knew about that. And it wrote function names that make sense, like has seen event, and send Slack notification, and mark event as seen. Like, I wouldn't have written that. Mine would have been check thing, send thing, log thing, right? And it knew the structure of the Dynamo requests. Now, those in the room that know Dynamo well enough and can read that fast enough will know that doesn't work, but it was very close. It was close enough that it got me interested in spending the next 90 minutes of my life to build the platform. So that solution, by calendar clock time, took me about 3 hours. My fault, I got stuck down a rabbit hole on one of the stupid things that I didn't really know. Effectively, it was probably 90 minutes worth of work. Now, there are a few caveats to that. Some of the patterns of deploying this and other things that go around, we already have examples of, right? We've got patterns that we built. But I was able to go from this idea of, wouldn't it be nice if I could have a function that could stream any access denied CloudTrail event to a Slack channel that needs to validate each event and only notify me within 24 hours. I didn't mention DynamoDB in there. And literally, that's a screenshot from ChatGPT. What's cool is, if you haven't used it, is this stuff. Not just here's a regurgitated chunk of code, but and here's how you use it. This is what this means. This is what this does. Well, write me the CloudTrail, like CloudFormation. Well, here's the CloudFormation. Write me an EventBridge rule. Now, this is a bit wrong, but luckily I'd spent $80 the day before writing Athena queries, so I knew what I was looking for. But I could take the syntax and swap out event name access denied with, I can't remember what it's called now, status, error code, the error code access denied. But the structure is correct. The filter, the content is right. It's just a little, it missed a little bit of context. And actually I can't find any documentation that explains that that error message will be consistent everywhere. It's just a learned behaviour of consistency by the AWS devs. In fact, there's actually 2 different parameters they'll usually give you. And of course, the most important piece is documentation. So write me the README file for generating the Slack token, because I didn't know how to do it. I'd never used that method of integration before. I'd used the request, I know how to go into Slack and add a webhook, but there's this like extra. Well, there you go. Certainly, I love it. How proper it is. Click on this link, go and do this. Oh, hang on. So, well, look, we're there, right? So this is the thread, right? So the funny bit is, it's like you're in my head. So write me the README file, right? What was my next prompt? What's interesting is that's already marked down. I didn't know. If you copy that, it's already marked down. Because it wrote the same thing, and I'm like, that's not marked down. Yeah, yeah. So then I'm like, oh, what else? What other things can I do, right? And so it went a bit crazy because again, I've stopped giving it context now, right? I just started asking really stupid, like I'm treating it like someone on the other end of a Slack message. Hey, just write this for me and write this for me. So I did a few things that it wasn't very good at. What I wanted to get down to is, so expiration, it didn't do very well. I had this bug. This was interesting. The salt ciphers, I actually deployed it and it hadn't worked. And I was on Stack Overflow. I think this is the rabbit hole I went down for 90 minutes. I was off on Stack Overflow trying to find the answer to what, there's a Python library compatibility version here somewhere that's breaking and I don't know what it is. In the end, I think, no, this didn't help me. I think it might have been no, you got to lock it to 2.0 instead of 2.1. But I think it was Stack Overflow that solved that for me. And then I got kind of experimenting, right? So now I'm like, well, what if I didn't know some of the things I knew, right? I knew how to write a SAM template. I knew how to write a function. What if I didn't? Could it give me that too? Could it help? So again, boilerplate structure for what I'm looking for. What I find really cool is because it's working in context, it brings things like the names of things into what I'm doing, which is, if anyone's written this stuff, you mostly live on, well, if you do, live on the documentation, you scroll down to the bottom and you get the examples and you copy and paste them across and you're using YAML, not JSON anymore. But you've still got to then go and work out what all those parameters need to be and how they get passed through. This does that, but it also helps contextualize it for you as well. Super powerful. The last one I wanted to get to was I was looking at, I knew there was everything that it had done, it had provisioned like billing for DynamoDB. And I got a feeling that was expensive, which I asked it a bunch of questions about that, which it answered, and it told me, no, it's not going to cost you anything, but I didn't believe it. I eventually got to this. This was one of the most interesting queries I'd written. So show me 5 different examples of how to write DynamoDB tables. That's it, right? Like obviously a bit of history that we've been talking about here. But here's a single key example. Here's a table with a composite key and provision capacity. Here's a GSI example. Here's a table with TTL. And the one that actually I needed in the end, which fixed my problem, was moving from provision to on-demand. Here's an on-demand capacity. So a really simple, give me a broad set of examples would be the type of thing that you might have to go and trawl through 3, 4, 5 Stack Overflow, or 4 blog posts, or someone, maybe one of you guys has written the 95 different ways, the universal guide to. But if I wanted 15, I could ask for 15. Or I could ask for something else. Really powerful. Doop-doop. Let's go back here. All of this was just full. So, look at that, I'm not bad on time. It's pretty good for me. So, a reminder of who I am and what I'm motivated by. I like to see cool tech used in interesting ways to solve cool problems. And I like the sustainable delivery of solutions. So it's been a talk of 2 parts. One was around serverless and event-driven programming and events and APIs, and the other one is about leaning into some of these cool, interesting tech. Maybe it's not load-bearing. Maybe the AI isn't the tool that you're deploying in production, but maybe it's the tool that's helping you write the tools that go into production. So the 5 things I would encourage you to take away from tonight is, 1, if you want to get into event-driven programming or eventing stuff, that and serverless are a match made in heaven. All of the boilerplate ball-nang of connecting up queues, and it's all done for you. It's 6 lines of CloudFormation. It's really quick, lets you get in, but it's also a great way to learn it. So the one thing that I will say is the AWS API with what it does in EventBridge is a great way to look at what a domain model for events can look like. By just putting what I used to do was I used to just put a simple Lambda function on an EventBridge rule that would just write to CloudWatch. And then I'd go and read them all. The cheaper way to do that now is have the EventBridge rule go to SQS, and SQS will just buffer them, and then you can just go in and read the 10 you need and throw the rest away. Means you don't have to deploy a Lambda function. It's like 4 clicks in the console. So if you want to learn events and how events work and retry and all of that, the stuff like the bugs we've got in this pattern at the moment, where if 50 of these things happen in parallel, which seem to happen for some reason, the API spits out the same thing. Lambda scales up and runs 50 of them concurrently, even though Dynamo's there. It misses the lock and it floods the channel. So I'm like, oh, we've got to fix that, right? But all of those problems that you'll have building production-grade solutions on top of event and serverless type systems, perfect playground to learn that, to learn those patterns, to work out queuing and repetition and stuff. We didn't talk. I didn't thread the sustainable into my talk enough as I'd hoped. I only had half an hour. Happy to talk to you more about that afterwards. But I am a convert. I haven't run a server or a container probably in 2 years now. Nearly everything I do is serverless because it solves all the problems properly. Makes it a lot of, if you can't, as I said, if you can't get it done in a serverless context, you should think about the way you're going about it. Not everything fits there, right? Video processing, go and talk to the AWS guys about video processing and not putting that in Lambda, but for a lot of everything else, works really well. And don't discount LLMs. There's a few hands in the room that would agree with me here tonight, but don't just write them off as a fad to write your uncle's birthday party or write your daughter's basketball training schedule. It's got a bunch, it has indexed everything. It knows the AWS docs and the Google docs and the everything docs better than you do. And it's really good at building you bespoke answers to questions if you know how to ask them the right way. And on that bombshell, I think we're done.
Does anyone have any questions?
Thanks for your presentation. Just a bit curious, actually. I think the GPT model that you're using by the logo of the GPT was probably 3.5, right? I was wondering if you've already tried using 4 as well and seen the difference.
Sam asked that question earlier. Right there. Interestingly, my honest answer is I don't care. Like, I probably will, but I came at it as a pleb to the world and it solved all of my problems. So if there's a bigger number and it's worse, then I want to go back to the old one. It's on the list of things to look at and try to understand more under the hood, but the pervasive nature of how quickly it's able to give answers to questions, to things that is good enough. It's good for right now. Like, what people will do with it in the future, awesome. But yeah, no, I don't know. You tell me what I was using. I don't know what version of that it was.
Thanks.
Thanks.
Thanks, man. That was an absolutely awesome presentation. I was just going to ask in terms of, and what I would have expected if you got a really big organisation, you got literally every access denied, and even if you're trying to cache it, I would have expected that chat to be completely flooded and just constantly pinging. But you're saying it was actually a manageable volume.
Yeah. When we're not on record, I can show you how little is actually in there because it's got people's names and other things in there. But yeah, what I was surprised too, right? I was expecting to see a lot more stuff failing, but that's an expensive activity, right? There's some compute activity, something somewhere making a call for some reason. If it's doing it repetitively and it's wrong, it's banging your head against the door. So the aim would be with this to go back to the team and say, did you know you've got an X constantly failing there? Like the storage gateway example, because it shouldn't fail, right? Like if we're building things properly, if you're using the inability to access something as a control mechanism in your logic, think again, right? That we should do that some other way. So yeah, there wasn't a massive, there might be under the hood, like there might be like 6,000 of them coming in a 24-hour window, but the solution dedupes them out and only shows me one.
Questions? Anyone? Oh. To run.
I really like the idea about what you told about the using EventBridge and Lambdas. And I've seen many other people using Kubernetes and everything, but how do you persuade? I mean, I just wanted to know from any one of you, or, including yourself. So I just wanted to know any thoughts on how do you persuade someone to use more of Lambda and EventBridge versus Kubernetes?
Show them the bill.
Something like- Yeah.
Show them the bill. Yeah, yeah. Look, I do have an ideological belief against Kubernetes because it's overly complicated and does things it shouldn't do. But if you look at the run cost of a kube cluster on its own, it's 20 to 15 to 20% of it's just the cluster itself running. I pay nothing when my Lambda function's not being executed. There's some really cool, again, well off topic, I'm happy to talk about it later, but we've installed some really interesting kind of API gateway serverless-based solutions that I was expecting was going to cost us like $10 a month. And we've got daily cost reporting that runs Lambda functions into Slack channels, and our bill went up 1 cent for running this big serverless solution because it's not used very much. It's clicked on 6 times a day. But it's fully functional and ready to go when you need it. How do you do that with a kube cluster that has got something that you access 4 times a day? Like, you can't. So, cost. All good? Thank you, everyone. I'll be around working on pizza. Come and grab me.
Pizza's the back, vegetarian to the right, everything else to the left.
Okay, welcome back for part 2 of tonight's event. So, the second talk is training AI to do my job before it takes it from me. It's a very scary thought. How I built Klaus, my fully automated, artificial, semi-intelligent future YouTube star. And I, for one, welcome our new overlord, Klaus. This talk will be given by Matthew Merriel, who is the principal consultant at CMD Solutions. And I just learned, just by speaking with him a few minutes ago, that he is the holder of the golden jacket. Ooh. Now, if you don't know what that is, it means that he has all AWS certifications. All of them. What a star. I don't know, is everybody as impressed? Yeah, please. I'm like so impressed.
I'm more impressed that he's got the SAP one.
Yeah, exactly. You have to get the SAP.
Yeah, just don't ask me about it.
Like, you got to get them all right, SAP and pros and specialties. It's incredible. So I'm just so impressed. I'm like, wow, man. Well, anyway, I've got nothing more to say. So please welcome Matthew.
All right, let's get this show on the road. So, training AI to do my job for me before it takes it from me. Yeah, story of a budding YouTube star, kind of, sort of, maybe, probably not. So, as was just mentioned, my name is Matthew Merriel, Principal Consultant here at CMD Solutions based in Melbourne. I'm an AWS community builder. I was officially recertified as an ambassador on Monday, so that's a thing now. And I've got the AWS golden jacket. I can't believe it's in the cupboard at home and not on me right now, but that's okay. Yeah, free time. I spend my free time trying to, automate my day job because I'm lazy. I mean efficient, lazy. But I'm not actually going to do the talk tonight alone. As was mentioned, I'm going to here tonight to talk to you about Klaus, my YouTube star. So he's not going to work because, of course, not. So if you give me 1 second, it's probably the audio's done its thing again. Boom, 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 boom. So you set up the audio during the dinner break, and it goes and gets upset. Boom, boom, boom.
Well, hello, you lovely people. My name is Klaus the Cloud Cat, and I'm the second half of the dynamic duo here to present to you this evening. It truly is an honor to be let out and talk to people about how I've been brought to life and how my innards actually work. I'll let Matt get on with the presentation, and I'll be back a little later to get into the detail.
Klaus, will you take over? Sorry, we're having some technical difficulties with the recording. So yeah, Klaus. He's the cloud cat. He's going to tell you everything you need to know about the cloud once I actually, get this working the way I want it to do. So, why am I here? Why does Klaus exist? Partially because he can. But also, as I mentioned, I'm a community builder, an ambassador. Main part of what that means is AWS expects me to produce a lot of content. Teach people how to use AWS, teach people about new AWS services, which is absolutely fantastic, except creating content takes a lot of time. Writing blogs, editing videos, recording a video, not too bad. Editing the video so you can put it up on YouTube takes for freaking ever. I was lucky enough at the beginning of the year to become a dad, which means I don't have time anymore. You think you've heard about how much time you won't have? Yeah. It's less. Lots less. But as Goldrat teaches us in the DevOps mindset, if you don't have time, time is a constraint. Constraints are to be exploited or elevated. So what do? We automate. Pretty simple. If I don't have the time to create the content, I will write a bot that does. The really nice thing, the tricky sort of meta on all of this is giving presentations like this on how I automated the creation of content is also content. So I kind of kill two birds with one stone here. Kind of a nice little workaround. So for some of you will have heard part of this speech back at the user group earlier on in the year, but we are actually on version like 2.5 of the platform at this particular point in time. But to give you a little bit of a background on what version 1 looked like.
Well, it's a serverless application that allows a user to provide a piece of text, say a script for a YouTube video, and submit that in an API gateway. The application will then automatically generate the video, including all the required animations, and upload the finished product to YouTube. In a future version of the platform, you'll soon be able to provide nothing more than a subject prompt. But no guesses on how that's going to be done. But for now, let's just dive into what makes up the platform and how it works. It's actually not all that complicated once you break it down into its individual components. As you can see to the left of me, the platform is made up of nothing more than an API gateway, a couple of Lambda functions, some S3 buckets to put the data in, and a step function which contains the magic sauce. We'll dive into the magic sauce part a little bit later, but for the moment, let's start at a high level and work our way down. The solution can be broken down into two main parts. The first part is what's called the submission component, which contains the API gateway for users to submit jobs and get updates on their status. A Lambda function that accepts an incoming payload and one, saves the incoming text file to an S3 bucket for consumption by later processes, and 2, writes a record of the job to a DynamoDB table for tracking, auditing, and the future web user interface. A lot of future improvements on this project. The second part is that fun part, the part we call the creation component. This is the part of the platform that creates the video. The first Lambda function is triggered by the data stream on the DynamoDB table and validates the job and makes sure it's got all the required attributes. Then we have the step function, which takes the inputs and creates our finished product. It uses a separate S3 bucket to store all the generated artifacts it needs along the way. It then writes the video to the output S3 bucket where it can be fetched by the user. Or the upload Lambda function can upload the video to YouTube for us automatically. And as far as the bulk of the application is concerned, that's it. Not a lot to look at, and at a high level, not particularly interesting. But what about that step function? What's inside that little nugget? Well, here it is in all its fine glory. An unimpressive looking step function, and one that desperately needs error handling and logic checks added to it, but one that is fine for the moment. Famous last words I know. Starting at the beginning, the step function takes the incoming text file that's been provided by the user and rips out a whole heap of stuff. The reason we need to massage the text first is that we're going to want to generate speech of our text. But the text file also needs to contain other pieces of information, such as when we want images on the screen, what background we want, and so on. So all the information needs to be stripped out before it's passed to the next step, which is actually 2 steps. We pass the same text file to Amazon Poly twice. Once to get back a wave recording of a completed speech, and one to generate the associated metadata, which contain details like when each word or phone meme was said, which we'll need later when it comes time to lip sync my movements with the tech. In the interest of full disclosure here, the current version of the platform works a little differently and uses a third-party text-to-speech engine, but we didn't get time to update the images with the new steps. But the process is essentially the same. Once the WAV file and metadata are returned, we can calculate all the audio and video parameters, the metadata that was returned, as well as having details on when each word was said. Also contains information on when each image should be discovered in relationship to the length of the audio. So we need to align all the pieces together so that we know what needs to go where in the video. Once we've got that, we can create the master of all CSV files. We generate a row in a CSV file for each frame of the entire video. 30 frames a second for every second of footage, based on the length of the audio record. This serves as a list of frames that need to be drawn before being stick back together again, which leads us to the draw frame component. This is a distributed map component that takes the CSV file and fans out the records to an army of Lambda functions. Each Lambda function gets 10 frames to draw, and using Pygame, draws that frame and saves the output to an S3 bucket. For a modest video like this one, you can have hundreds or thousands of Lambda functions running in parallel. Distributed map handles all the retry and back-off logic, making it a really easy way to scale out your process. Thank you, or Invent 2022. The next part is the bottleneck of the solution, and one I've been meaning to fix for a while. For a 10-minute video, we now have 18,000 PNG files sitting in an S3 bucket that need to be stitched together to create a video and an audio track that needs to be overlaid with it. This is super easy for FmpEg, and FmpEg is easy enough to run in a Lambda function. But it doesn't scale very well. It's one of those, it works as long as the video is less than about 15 minutes in length. And a recursive distributed map of FmpEg jobs could fix this. Matt just hasn't gotten around to it yet. But either way, we get to the final state of the step function with a finished video ready for consumption by our adoring fans. It's not the coolest way to create videos, but it's quick, easy, and it's been a super fun project to build. And with that, I'll hand it back over to Matt to close out the presentation.
Not really going to close it out just yet, but I couldn't be bothered going and generating new video and all of those sorts of things. And it worked. Like, that was all generated from nothing more than a text file and a couple of images that I upload in parallel. Kind of. You've probably noticed that there were a few issues with the recording. The voice is super buggy and repeats itself a bunch of times, and there is way too much effort that needs to go into around how it's going to pronounce things. That was generated with the third-party service, which was PlayHT. Great service, really easy to use. The API is super simple. I originally started using them because I wanted the voice cloning technology, because AWS said they wouldn't count the content if it was Klaus's voice instead of mine, so I figured I'd just redo the videos with my voice, and then all would be well. But yeah, voice cloning is one of those things, it's a work in progress. So PlayHT was sort of causing a lot of problems with the sort of repeating audio and all of those sorts of things, and it was just going to take way too much time and effort to try and fix it. Plus, we were sort of at the mercy of their platform. You can't reprocess video if there was an issue. So if you realize that you edited your text file in Visual Studio Code and it had spelling mistakes and you upload it, you've got to wait for the whole process to finish, generate the video, watch the video, realize that it mumbled the word, and then you've got to go back, edit it, and rerun the whole thing. There's no way to go edit in flight or pre-generated videos and then reprocess just the replacement bits. A lot of work to generate the text file. I'll get into a little bit more as to what that looked like later. Adding additional functionality. So yes, you can upload the text file, but what about making it super simple, like adding things like ChatGPT? So rather than the text file, I just go, write me a 10-minute video on how Amplify works. That became really hard because, and again, I'll get into the details in a little bit as to why. And again, front matter of the text files around defining scenes and what character and what positions just, yeah, was causing some real problems. And then finally, you know, as with any V1 product, yeah, let's have it upload to YouTube automatically or just save it to an S3 bucket. And then it's like, but we also want to post it to LinkedIn or we want to post it to Facebook. And now I'm back to having to do manual work. It's great if the video is automatically generated, but if I've still got to find time to sit down at the computer, log into the S3 bucket, download the file, log into Facebook, it kind of defeats the purpose and the video doesn't get uploaded. So, as with anything, you start iterating and you start going back, and all of those it doesn't matter decisions that you made back when you wrote the application and you went, yeah, nah, she'll be fine. Yeah, you go back and you start replacing them all. Starting with the API gateway. Binary data through API gateway. Anybody done it? It works, sort of, pretty limited, doesn't give you a whole heap of options. It's great. You can literally just pass, you know, the text file as a binary object to the API endpoint, ingest it, and off you go. Except you've kind of just shot yourself in the foot for all the other things that you want to do with API gateway, and multiple endpoints becomes difficult. And there's a lot of gotchas around that one. You know, it worked, but not great. So we sort of broke it out and had a little bit of a think about it, and now we sort of go on a more traditional sort of, you know, CRUD style solution here. Also, you know, we wanted to add some other things around. We've got multiple types of videos that we want to produce. You know, we've got the news segment, which I'll show you a little bit later, and we've got the stand-up, and we've got the podcast. So we wanted to be able to add templates so that we don't need to then front load all of that stuff in the text file. We can simply say, this is a podcast style video, or this is a, you know, studio style video, and then just have it know what that means and goes and fetches it from that table. We wanted to pull in multiple assets. Having a text file is great, but it also shot us in the foot a little bit when it came to, I've got this block of text that I want like the intro to my video, if you want, you know, standard intros and outros for your videos, but then I want ChatGPT to do all the stuff in the middle. It kind of meant that we had to do ChatGPT on, you know, our end user device, stitch the text file together and then upload it, and we sort of lost the ability to, you know, do all of that automatically. So we've added assets and the ability to sort of define, I want this static piece and then I want that or AI generated piece, and then I want this static piece and I want these images, and then I want you to go to Midway and generate the images that I don't already have. So we sort of built all of that out, and that made life a hell of a lot easier. We also, you know, did the standard, you know, signed URL in order to get around the binary data problem. We didn't do that originally simply because, you know, curl in the command line, super simple. Obviously, with signed URLs and all of that, it's a little bit more work, but let's face it, smashing together a simple little Python script on your machine that makes 2, you know, REST calls is not that complicated, and probably should have just done that from the outset. It would have been so much easier. The other thing we did with the API gateway that was sort of one of those, it's fine for now, API keys, user keys. You know, we wanted some security on the API endpoint so that people couldn't just, you know, go, ha, 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 ha. Here's a 10 meg text file that's going to generate a ridiculously long video and just burn your credits. API keys are great, right? Like, they're a level of security. There's nothing confidential in this platform, and at the end of the day, you know, if somebody does upload a 10 meg text file, well, it'd only be 5 meg because you can't only do 5 meg on a binary API endpoint. And even that's only going to cost like, you know, 20 cents or something to run. So it's like, yeah, even if it does get compromised at the end of the day, it's not that much of an impact. And then, you know, bill triggers and bill alerts and all of that are going to kick in, and you can go in and kill the key. The problem is, now that we've got multiple API endpoints and we want to be able to upload individual assets and define templates and all of that, we need some kind of user interface, which means we're going to be talking some kind of Amplify front end. Now user keys can't really be defined in code, and we're getting dangerously close to needing Cognito. Yeah, I really don't like Cognito. Like, it's just way more work than it should be. But it was sort of one of those things that's like, again, if you are updating the API, you should do that at the front. The next sort of issue that we needed to address was the data schema. Originally, we started off with a text file because text file, easy, right? Just write the text, upload it to the API endpoint and have the video generated. Super simple. oh, but we wanted to be able to display images and we want the character to be able to move and do animations, and this should come as no surprise to anybody. Yeah, text files, like plain text is really not a good way to define a data scheme. All right, like it turns out you need some kind of structure because otherwise things get really messy really quickly. As an example, this is the text file, or the asset payload now, that generated the co-presenter introduction that Klaus gave before. Right? Relatively simple, and you look at that and go, well, that's actually not too bad. You define what the background's going to be, or what the scene's going to be, which is the stage that he was standing on. You define what character it's going to be. In this case, it's Klaus. We've got the idea of having multiple characters and all of that, but we'll get there one day. And then just a block of text. Relatively simple. But if you want him to move and sort of turn his body, you need to start putting actions in there. So now you start putting these blocks of text in your text file. And again, it's not super bad, but when you start building this out, your text file gets really messy. And this is why we sort of started breaking things up into, well, if we have blocks of assets and a template that says this is how it works, we can simplify it straight back to just, here's what I want you to present, just go and do it. Yeah. Doesn't scale particularly well. The other problem was, again, back to the binary payload problem, was we wanted to add a lot of functionality that we'd only use in some videos. So a prime example of this is want to do a weekly YouTube video on all of the new announcements about AWS. I know Jeff Barr and the team do theirs, but I can automate this and have it out before they do theirs, and I can beat you at your own game kind of thing. Because I can. The problem is we want to do some comprehend because we want to scrape the RSS feed, do some comprehend, then we want to do some personalize and some sentiment analysis and categorize it and all of this, but we only want to do it on certain types of videos. And again, this is where the binary payload thing with a single text file doesn't really work, because again, we need to do all that generation and scrape the RSS feed on the end user device. That doesn't really work. So again, what we've done is by being able to define the individual assets within the project, so we've got a project that has multiple assets that pulls from a template, we can define a lot of that and have a lot of that calculated in the cloud, and then just use the generate payload Lambda function to go, right, well, the project defines that it's this asset block, which is a block of text, then this asset block, which is a call to ChatGPT, and then this asset block, which is a call to Midway, and then this asset or Midjourney, and then this block goes and fetches this, and then we stitch it all together, and that's what we pass to the step function. Easy. That makes life so much simpler because it means that we're just building this big JSON payload that we can then pass to the step function, and gives us a lot of flexibility around what functions we want in what videos defined by the template. Nice and easy. Speaking of which, this is sort of talking about the ML AI functionality bit. If I turn around and go, I want a 10-minute video on Amplify, that comes in as an individual asset in the DynamoDB table. The event stream off the DynamoDB table goes, this is a ChatGPT prompt, go to ChatGPT and pass it this prompt, pull back the response and stick it back in the asset table, where it can then get pulled by that generate payload Lambda function and go into the video. The nice thing about this is we obviously started with ChatGPT because, as Stephen said before, super simple, love it. The API is even easier to work with. And dirt cheap. In fact, if you go and get a GPT-4 and you can get 8K, request sizes, and you can go down that rabbit hole, and then you can get 32K if you're nice enough to them. But what we've also found is there are other things that we want to be able to do as well. Not the least of which, if we want to generate those weekly videos on AWS announcements, ChatGPT's dataset doesn't get updated that frequently. We need to do that ourselves. Hello, SageMaker. Always been looking for a reason to use you. Let's start building our own models and start pulling our own data in, and then we can run it through. We can use AWS services to critique the AWS what's new announcements in their own RSS feed and then upload it back. Yeah, and yeah, can you see the circle starting to occur here? What's nice about this is by simply defining within the asset payload what type of call it is, we can pull from multiple different machine learning models, machine learning services, and all of that, and not be restricted to any one particular type. That's worked really, really well. The audio was the next one that we sort of had to go back and fix. Version 1 was Poly, because, well, it's there, it's simple, it's an API call, and it is dirt cheap. Like, you think Lambdas are cheap. The free tier for Poly is like 1 million characters if you use the natural sounding, and like 5 million characters if you use the standard. Do the math, and that can be like, you know, days of audio. So if I'm doing a 10-minute YouTube video every week, like that's 52 videos at 10 minutes a video, you know, you're sort of talking like 8 hours, 9 hours of content. Like, yeah, this is all going to land under the free tier with like an order of magnitude left over. Thought that was really cool. But then I had that crazy idea about, you know what would be cooler than that? Is if it was in my own voice. Because then people would think that it was actually me doing it and not an automated bot. So we went to Play HT. And we found out a couple of things. One, it's got some bugs. Second, and more importantly, voice cloning is not as easy as it sounds. And it's nowhere near as good, higher quality as it sounds. The amount of training that you've got to do to get it sounding particularly well, and you've probably noticed I have a kind of odd speaking pattern, which is really hard for the models to sort of nail down because it thinks I'm either screaming everything or whispering everything. So you run it 10 times and you get 10 wildly different things. Plus, because it's a third-party API service, you've got to kind of do your own error handling and you're waiting because it's all asynchronous. Fine, easy, like the step function is not particularly complicated. In fact, most of that is pulled from template, you know, using the Workflow Studio. But it's just more work, and the aim of this whole project was to like reduce the amount of work I was doing, not increase the amount of work I was doing. So we had a little bit of a play, had a little bit of a look. We decided the complexity, totally not worth it. So we did some research and went, hey, you know what worked really well? Poly. So we went back, because it works and does what we need it to do, and you know, nice and simple. They will do voice cloning. They will not tell me how much because they guarantee me it is like 6 zeros more than I can afford. So, yeah, okay, it's going to be one of their voices for the time being. That's fine. It works. And then lastly, the step function. This is not so much what we did. This is more just a warning for everybody in the audience to not do what we did. Sketch it out before you start coding it. I know that sounds like a crazy thing. You know, have a plan before you just start opening VS Code and hacking away at it. Stitching things one after the other is really easy in step functions, and you just say, I'm going to run this Lambda, and then I'm going to take that output and put it as the input to this Lambda, and then I'm going to have a condition, and if it's this, it's going to go this way, and if it's false, it's going to go that way, and I need this piece of data to make a decision. I'll just stick it here, and then you get to the end, and you've got this hodgepodge data payload in your step function that's incredibly hard to update, hard to understand, hard to debug. Just grab a napkin and just go, okay, I'm going to take a text file. I need a video at the end of it. What are the steps that I need to do, and sort of map out, and for each step kind of go, right, what does this need to come in order to do its job? What does it need to output in order for it, for the next person to do their job? And have a little bit of a plan before you go. You will save yourself so much time. We wasted days on that. The other thing is distributed map. Has anybody played with distributed map? Yeah, I love it. It's so simple. You can literally just give it a CSV file and say, for each record in this CSV file, go and scale out my army of Lambda functions. And then just get me back the payload, like stick the payload in an S3 bucket and let me know when you're done. It could, and as the video said before, no error handling, no back-off logic, no retry, because it handles all of that for you. It can do transforms and all sorts of bits and pieces. It is fantastic. That's how we can do all of the complex, funky logic with very little effort. So that kind of led us into all of that mashed together with a little bit of extra sauce, landed us on V2, which is that. Most of it is somewhat similar. And I'm kind of going to run through sort of the high-level bits and pieces of this because I don't want to bore people too much. I am maybe going to open source this. I'm a little undecided yet as to whether or not I should weaponize low-quality content creation. That feels like a bad idea, but at the same point in time, if people are curious as to how this works, I kind of want to share the knowledge, so it's kind of that catch-22 thing. If people want to try and convince me one way or the other, more than happy to hear your opinions. As I said before, sort of we got a couple of endpoints now to help manage the assets that we want to upload, the template, so that we can get some repeatability happening. The project, so one project pulls from a template, gets lots of assets, so that we can then generate a video at the outcome of it. At some point in time, I'm going to need to stick a front end to it. I've started building a front end like 4 times, and every time I do it, it reminds me that I hate front end development. It's just not my thing. Right? Yeah, I know, right? Like, UI is just not a thing for me, right? It's, like, if I enjoyed all of that sort of stuff, I wouldn't be automating the video creation process. I'd be doing it myself because I'd enjoy it. Yeah, I'll get there one day. I'm thinking like a React admin or something to just like get rid of most of the heavy lifting. Again, anybody got any good ideas on how I can simplify that process? Let me know. Maybe a platform that automatically generates, an admin portal, something. I don't know. Yeah, so the asset table, as I sort of mentioned before, this is sort of where the secret sauce comes in for all of the content that gets generated that I don't want to have to write myself. So we're pulling from a bunch of stuff. There's the jump starts that AWS have been really pushing around a lot of the new models. I know that Llama 2 was announced yesterday. That's on the to-do list for this weekend because the in-laws are here and it sounds like a good reason to go hide in my room for a couple of hours. The event stream Lambda comes from the video endpoint. Video endpoint's pretty simple. It's there so that you can say, right, the project's set up properly, all the assets are there, go ahead and generate the video. That's really complicated. That's just an event stream off the back of the DynamoDB table. Super crazy. And then it fires off the Lambda, the step function. The step function is, if I just take, I just wanted to double click on a couple of things super quick. This, anybody use Workflow Studio for step functions? Yeah? Hallelujah. Oh my God. So this is another one of those don't do what I did. Being the Golden Jacket Community Builder Ambassador, I'm too good for the UI. Did the whole thing in Visual Studio Code, just hacking away and yeah, don't do that. Use Workflow Studio. It is literally drag and drop. I want to run a Lambda. Then I want it to run into a parallel process. Then I want it to do this. I want to, have this as the input. I want to have that as the output. Here's what I want to do for the error handling. And then give me the code so that I can go and stick it in my source code repo. Like, gets rid of all of the annoying write the code stuff, but then still gives you the actual asset that you can then go and stick in your source code repository. Could not make life simpler. Highly recommended. But as the video sort of outlined, there's not actually that much to the whole process. This is the distributed map that I was sort of talking about before. It's literally a distributed map. Take the CSV file from generate schedule and then scale out the Lambda function. Really not that scary. It's literally just a whole bunch of PNG files stuck in an S3 bucket. And then stick them all back together using FFmpeg. I really, really wish that Elemental had a way to stitch PNG files together efficiently to create a video. That feels like something that Elemental should be able to do, but I can't work out. Like, it doesn't look like it actually does, which is kind of annoying. But we'll get to that. Use Workflow Studio. Makes life really easy. The other thing that I wanted to just jump into quickly is, if we have a look, I really wish that I wasn't trying to jump across. I've lost my mouse. There we go. It mentioned before the marks, the markdown from Poly, that sort of says when each image is going to be needing to be displayed, when each phoneme is going to be displayed. For those who aren't aware, phoneme is the mouth shape for a particular sound. This is the payload that Poly comes out if you ask for speech marks. It gives you the timestamp what the particular asset type is and what the value is. So if you're using your SSML and you say, you know, the quick brown fox jumped over the lazy dog, give me the WAV file and give me the markdown, this is what you will get. So if you then scrape through this and go, okay, now at 400 milliseconds, which is frame 7 of second 1, what shape does the character's mouth need to be? Oh, it's an S. Okay, cool. Now I know what to draw his mouth as. It makes life really, really easy. If you use the, I believe it is the mark SSML value, is you can just put individual statements in there or individual values, which will come up in this file but will not actually be spoken. That's how the images are done. So I just turn around and say, you know, image goes here, image goes here, image goes here in the SSML, which is just the text file. The text file gets converted into SSML. So that when it comes into here, it knows the image comes up at 714 milliseconds, 1500 milliseconds, whatever the case may be. And then that all gets generated into that CSV file that it was talking about before, which literally just outlines, you know, what background, you know, what character, what scene, what phoneme the character's mouth needs to look like, and the timestamp. And this is what gets fed by distributed map into the individual Lambda functions. And it's not particularly interesting, but it works really well. Flipping back to the presentation, because I've gone way over time, so we might just cut back over. The end result of V2 is passing in a call to scrape the RSS feed of the AWS What's New, and you wind up with something
Welcome
like this.
Welcome to episode 1 of the Build in the Cloud's weekly cloud report. My name is Klaus the Cloud Cat. I'm super excited to be here to give you the rundown on what's been happening in the world of Amazon Web Services for the week ending May 7, 2023. As this is episode 1, I'd like to explain the purpose of this new series and the thinking behind it.
So that was generated using version 2. It was literally passing in the RSS feed, a date range, and the template, which defines that it's Klaus presenting on the newsroom scene. If you then hooked that API call to hypothetically, oh, I don't know, an event, you know, some kind of cron job that you might have triggered from your AWS environment on, say, a weekly basis, you've got your weekly what's new in AWS updates streaming to your YouTube platform every week. Relatively simple. So what's next? So I've got it generating the videos, I've got it doing all of that. There have been a few things that we've identified that we kind of want to add. The first one is, rather than outputting an MP4 file using FFmpeg, we actually think it'd be really cool if we output it to a DaVinci Resolve project file, because the really nice thing about that would be then if you wanted to just generate it and then go and add some extra stuff or embed it in somebody else's project, you've already got it there. The DaVinci Resolve SDK is not super great, not particularly feature rich, but they are just across the river, so you could probably just go and knock on their door and tell them to, you know, do better. Do better. Or, you know, ask nicely might be a better way to, you know, get what you want. Generate other content types. Videos, cool, great. You know what you can do if you want to sort of really amp up your content creation? Yeah, generate a blog article to go with the video. Yeah, already got the script, already got the API. You know, if we can generate video, we can generate a PDF document. That's pretty easy. Pose-to-pose animation calculations, and this kind of goes hand in hand with the next one. At the moment, all of Klaus's animations need to be individually captured as frames in order to be imposed into the video. Not super efficient. There are a bunch of machine learning models and some AI work that's being done to hypothesize you build a skeleton and it will work it out. That feels like a much simpler way to be able to get new characters and all of that, because people are going to get bored of Klaus being the only person that just stands here like this for 20 minutes and doesn't do anything. But that sort of linked into the, well, what if we just did 3D models in something like Blender, because Blender's actually already got all that functionality and we could just make an API call and that doesn't feel too complicated, and we can get Blender running in AWS, not entirely serverless, but yeah, maybe something. And that stupid web front end that I really need to work on at some point in time. So they're kind of, what version 3 or 3.5 or whatever the number is that we're up to now is kind of going to look like. Resources. This has been a fun project, but it's required a hell of a lot of learning along the way and a hell of a lot of trial and error. If you haven't seen them, step function workshops. In fact, just the whole catalog.workshops.aws, if anybody hasn't seen that, and you're looking for, hey, I want to learn how such and such works, yeah, go there. They have heaps of, how to get started with step functions, how to get started with SageMaker, how to get started with, all of these sorts of bits and pieces. They're, great. Reuse the serverless pattern, serverlessland.com. Again, if people haven't heard of it, whole heap of intellectual property. Like you want to learn how to do, a CRUD API, or you want an event stream pipeline or something like that, go there. They've got the patterns, copy the code. It's all GitHub repos, fork, clone, whatever. Pull it into your project, not an issue. Carrie KH, YouTube channel. Well, this is where I got the original idea for this. He did a few videos on this years ago. He was using his local machine and some other bits and pieces. I don't like doing things on my local machine because it's too hard and requires my laptop. But yeah, so that's sort of where I got the original. It's a really interesting series. If you want to go and have a look, he sort of dives into a lot more of the behind the scenes bits and pieces. I've borrowed a few of his ideas and then just slotted in AWS logic where it made sense. Again, serverless workshops, always great. Best practice for large serverless projects, again, go have a look at that. Really good information on sort of how to map this out and sort of not make a bunch of the mistakes that I made in building this project. Well architected, wouldn't be a community builder or an AWS partner if I didn't mention the well-architected framework at some point in time in my presentation. So yeah, there you go, overlords, I've done it. Look at the application, the serverless application lens, and as I said, sort of serverlesslens.com. A lot of useful resources there. As I say, I am umming and ahhing about whether or not I want to open source this. I will probably end up doing it because the videos are only so good, it'll be pretty easy for people to work out what's going on. Plus, you'd at least need to make your own character because not everybody's going to get Klaus. So, but yeah, just thinking about the potential problems that might cause. You got any questions? Happy to, answer them, anything like that. Otherwise, yeah, we are a little bit over time. But yeah. Yeah.
Questions? Don't be shy. Yes.
One thing.
Yep.
For your front end, check out Retool. Really great.
Retool.
Hacky admin portals and stuff. Fantastic. Second of all, I saw 4 DynamoDB databases.
Yes.
Why?
Because I'm lazy.
Good
Yeah. That's it. You know what's it? Yeah. You write the Lambda function to handle the CRUD, and then you stick the DynamoDB table there, and then you copy and paste 4 times, and voila. I wasn't. The real answer is it's kind of grown organically as we've sort of thought about what additional functionality we want. And we're still not 100%. Like, we know that the JSON payload that it stitches together is going to need to be rewritten in order to support some of the future stuff, particularly when we're wanting to do ML to generate some of the animations and that. So it was kind of and again, we built the new version of the API to solve the last time we went. It'll be right for the moment, but we kind of went, yeah, it'll be right for the moment, and we'll go back and fix it later. You can tell this isn't a commercial product.
But soon.
But soon. Yeah, I was told about, is it ShotStack? Yeah, a group up in Sydney that do a similar sort of thing, yeah, API-driven video creation. I was told about them last week. So I don't know, maybe there is money in this.
Questions?
Yep. What is Klaus is just a name. It was originally going to be Klaus with a C, so it's Klaus the Cloud Cat, so CCC. Just again, cause. But then I got yelled at by a bunch of people because apparently Klaus can't start with a C; it's got to start with a K. So that kind of went out the window, but by that point in time, he'd already had a name, and yeah, he's in my Git repo as Klaus, so it's kind of like, yeah, that's what it's saying. That's what it's saying.
It's a great question. I was thinking, cool, large, amplified, something serverless.
Yeah.
You can come up with any correct.
Yeah, look, there's been a few things where the acronyms have sort of landed on things that are like, I'm going to need to rename that because that acronym's not acceptable.
I have a question, and I think I missed
Yep.
the explanation, so my apologies. How do you sync mouth movements to sound?
Mouth movements to sound. So that is done by the markdown that comes out of Poly. So when we generate the audio, we make two requests to Poly. One to generate the audio, and then one to get the markdown of the audio that's generated, which gives us timestamps and what phoneme was said at what timestamp, which we can then use when we generate the frame by frame. We know that at 450 milliseconds, phoneme S was mentioned, so that's what the mouth is going to look like. And then we've just got some logic that says if Klaus, based on the template, defines where Klaus is and whether or not he's facing left or right or forward, it just does some basic math to go, well, that's what the mouth looks like when he's firing on. He's 70% to the left. That's what we've got to do to the mouth to make it look.
So you worked out what the mouth should look like
For each phoneme, correct. And then we've just got each of those saved as individual images in an S3 bucket, and it just pulls from that to stitch it all together. It's really not actually all that. It's really just a whole heap of pie game. That's really all the draw frame is just pull in individual components that make up Klaus, the character, his mouth, his head, his arms, stitch all of that together and then stick a background on, and if there's an image, stick an image on there as well. And it's just pie game, drawing screens time and time and time again and saving each one as an image, and then FFmpeg at the end going, that's the first image, that's the second image, that's the third image, and just sticking them all back together again. And that's why that's the massive constraint on the platform at the moment is a Lambda function running FFmpeg can only stitch so many images together before the Lambda function times out. And my original plan was to do kind of a recursive, break it up into pieces, stitch them, and then do an iterative sort of, generation thing, but again, I just haven't gotten there yet. Because, again, Klaus doesn't move his arms yet, so it's literally just Klaus standing there. So if I'm generating a video that's more than sort of a couple of minutes in length, people get bored and stop watching. So the need to generate a video that's sort of more than 15 minutes in length hasn't been there yet, but it will be. One day, maybe. I don't know. Depends on whether or not I get bored.
Awesome. Any other last questions? Here's your chance. No? All right. Well,
Good.
Let's thank Matthew. Thank you so much. I think this is the end for our meetup. Once more, thank you, Matt. Thank you, all of you. We're always looking for speakers to present. So if you are interested, this is a very friendly group. We'll give you pizza and beer, or drinks, any drinks you want. Nothing. I shouldn't say that, really.
Thanks to CMD,
Thanks.
they'll give you
So please let Matt or I know if you're willing to speak. That would be amazing. Yeah. Any other?
no. Hope you enjoyed yourself, and thanks to our speakers.
We really are. It's going to be so amazing.
You should have seen us 12 months ago.
It's amazing now.
That's right. All right, thank you. Thanks all.